Assalamualaikum warahmatullahi ta'ala wabarakatuh, and very good day to all my beloved students. So this time we will do another question or exercise related to the closed system. This is the question. A piston cylinder device with a set of stop on the top contains 3 kg of saturated liquid water at 200 kilopascal. Set of stop means that this stopper, okay, contain 3 kg, okay, 3 kg and 200 kilopascal. Heat is now transferred to the water, so heat or Q is transferred to the water, cause some of the liquid to evaporate and move the piston up. So by referring to this case, some of the liquid refer to the case of partially liquid and partially vapor. So actually we know straightforward that is the condition of the saturated mixture, okay, and move the piston up. So this piston will be moved and stop at this stopper. When the piston reach the stop, the enclosed volume is 60 liter, so meaning that when it reach here and this part become 60 liter, okay, more heat is added, okay, so heat is supplied continuously until the pressure is double. So the pressure is double means that initially the pressure is at the state 1 200 kilopascal, and doubles at the final state or state 3 become 400 kilopascal. Okay, so somewhere here and then somewhere here. Show the process on a Pve diagram with respect to saturation line. Okay, and amount of liquid at the final state, if any. So this one refer to the mass of fluid, okay, in a kilogram. B, final temperature. So we need to determine what is the temperature at the state 3. And last but not least, the total work and heat transfer. So total work refer to the W, and the heat transfer refer to the Q or Q net. Okay. So this is the step of solution. First thing first, determine each state and sketch a Pve diagram to assist you to solve the problem. And secondly, obtain the information from each state. Course, from property table, specific volume, quality and internal energy. Step 3, apply the work boundary condition to solve the equation. Okay. In this relationship, work boundary or WB equal to the PV, or we can write as well as mass times pressure times specific volume. So we may refer based on the information or the question relate to this equation. And then step 4, apply the conservation of energy principle, first law of thermodynamics of closed system, which is Q minus W, internal energy, kinetic energy and potential energy. Step 1, determine each state, phase and sketch of a Pve diagram. Okay, state 1, saturated liquid water at P1 200 kilopascal. Okay, so we can state over here 200 kilopascal, state 1, and this Q referring to the heat is add up continuously until it reach the state 3, which is double from the state 1 pressure, 400 kilopascal. Okay, so then we sketch the Pve diagram, knowing that state 1 is the saturated liquid, so we should somewhere start at the state 1, and then the state 3 from the question giving us the information of the saturated mixture. Okay, it should be underneath the curve graph, or else we can write this one more or less. Okay, so this line saturated liquid, and then this point 3 or state 3 underneath the curve, which is representing the mixture, saturated mixture. Okay, Step 2, obtain the information from each state from the table, specific volume, quality, and internal energy. So we are given the state 1, P1 equal to the 200 kilopascal in the case of the saturated liquid water. So we are referring to the table of saturated water at the P equal to 200 kilopascal, and we obtain the VF and the UF 0.001061 and 504.5 respectively. Yet we go to the state 3 with the phase of saturated mixture, and then we referring to the P equal to the 400 kilopascal, and we obtain the VF, VG, UF and UFG as stated in the details, which is 0.001048 for VF, UF 604.22, VG 0.46242, and UFG 1948.9. Step 2, obtain the information from each state from property table, specific volume, quality, and internal energy. By having this kind of equation, V3 equal VF plus X3 VFG. Since we want to obtain the X3, so we required to have the V3, VF, and VFG. From the table, okay, we can get the VF over here. VFG is not stated directly from the table, but we know VFG equal to the VG minus VF, which is here VG minus VF. Okay, and we need to obtain the V3 to complete this equation. V3 specific volume at the state 3. So we got 0.02. How do we get this value? Actually, from the question is given 60 liter, and then we convert it by divide 1000 to become 0.06 meter cube, and then to convert it to the specific volume, we divide 3 kilogram, which is referring to the question, and finally we get V3 or specific volume at the state 3 0.02 meter cube per kilogram. Or we can try to address this information in this form: 0.02 plus VF plus X3, which is quality at the state 3, and then VG minus VF, and we get X3 equal 0.041. Knowing that X3 representing the ratio of the amount of vapor in the saturated mixture. But the relationship here is the X equal to the mg, or mass of gas divided by the mass of total. But the question asks to get the amount mass of fluid. So what we need to do, we just deduct or subtract 1 minus X3, which is we obtain here, and times with the total mass, which is we gain from the question, and then we do the calculation to obtain the final answer, which is MF, or amount of mass in the form of the fluid, equal to 2.877 kilogram. Next, we want to solve the problem for the final temperature. I think this question quite straightforward, since we have the information at the state 1 200 kilopascal and the state 3 400 kilopascal, referring to the final temperature, so we refer to the final state, which is the final temperature, which is state 3. Okay, and also we know the state 3 in the region of the saturated mixture. So what we need to do, we just refer to the saturated water pressure table and go to refer the 400 kilopascal to obtain the T set which is 143.61 degrees Celsius, yet we get to solve the problem for B, which is final temperature. Then step 3, apply the work boundary equation to solve the third question. Using this equation, work boundary, okay, Pv, okay, P delta V, pressure times difference of volume, or we can use as well mass time pressure time the specific volume, the difference of the specific volume. Okay, so actually it depends what is the information available or the given data which us already provide or given from the question. And since all the information is available, so we just straight away insert all this information. Okay, mass 3 kg from the question, and P at the state initial state 200 kilopascal. Okay, and then the specific volume at the condition 2 or state 2 0.02. Okay, and then the V1 0.001. Okay, so knowing that the V2 equal to the V3, right, because it constant volume. Okay, from 2 to 3 is the constant volume, so that we use the same value of the specific volume, and we managed to get the work boundary 11.4 kilojoule. Finally, we apply conservation of energy principle or the first law of thermodynamics for closed system equation. So we need to address this governing equation, Q net minus work net equal to the internal energy, kinetic energy and the potential energy. Or we can write this equation as well in this form, Q net minus work out minus work in, and plus with the work boundary equal to the internal energy, kinetic energy and potential energy. Bear in your mind, we can simplify this equation by neglect not the information not available from the question. For example, work out, work in, kinetic energy and potential energy, and yet we can write in this form. And maybe we can try to rearrange this equation to become this form. Based on this equation, Q net equal to the internal energy and the work boundary, knowing that the work boundary we already obtained from the previous calculation, and the M is already given from the question, so we can write this way: Q net equal 3 kg internal energy at the state 3 minus internal energy at the state 1 and the work boundary. So to obtain internal energy at the state 3, so of course we need to refer the table at the state 3 400 kilopascal to obtain the UF and the UFG. Okay, 604.22, 1948.9, and then insert in the equation of the to obtain the U3, which is UF plus X UFG, meaning that UF is from here, UFG is from here, and X we already calculate previously for the state 3 quality, which is U3 equal to 604.22 plus 0.041, which is we already obtained from the previous calculation, and 1948.9 from the table. And we managed to get U3 or internal energy at the state 3 684.13 kilojoule per kilogram. So then we already solved the part of the U3. So to obtain the U1, we just refer to the table at the state 1, which is 200 kilopascal, and then referring to the UF. Okay, UF equal to the U1 504.49 kilojoule per kilogram, and then just insert all this information, 684.13, 504.5, all these things we already calculate previously, and the work boundary, which is we already gained from the previous calculation, 11.4 kilojoule per gram. And then we just do the calculation, and finally we managed to get Q net equal to the 550.2 kilojoule. Okay guys, so this is your part. I try to do this question. It most similar with the previous question that we have been discussed earlier, but it's a change a few value or data or parameter, which is 2.5 kilogram for the mass, initial pressure or state 1 pressure 400 kilopascal, and also the volume from 60 liter to 80 liter, and the rest still remain the same. Okay, A, B, C question. But do not get worried, as usual, so also provide the final answer for each question, A, B, and C. But if you found that this answer is incorrect, so you may jot down in the comment and specify which part is the incorrect, so we try to look back and try to do the correction, or else maybe do the wrong calculation or typo or something, so it should be no problem. With that guys, thank you very much. Stay safe. Assalamualaikum warahmatullahi taala wabarakatuh, and have a good day.